Have you ever wondered what the universe is really made of? This enigma has puzzled thinkers for centuries. At the heart of it all lies particle physics, the study of the tiniest building blocks of the universe. From quarks to leptons, and from gravity to electromagnetism, these fundamental particles and forces shape every aspect of our reality. They are the unseen architects of the cosmos, the silent puppeteers of existence. So come with us on this journey, as we delve into the intriguing world of particle physics. The story of particle physics begins in ancient Greece. A group of thinkers, philosophers, and truth-seekers were wrestling with the fundamental question, what is the world made of? They proposed the concept of atomos, an indivisible particle that they believed was the smallest building block of the universe. This idea, as rudimentary as it was, laid the groundwork for the scientific exploration that would follow thousands of years later. Fast forward to the late 19th century. The stage was set for a new chapter in the annals of science. The year was 1897, and a curious English physicist named J.J. Thomson was tinkering in his lab. Thomson was examining a curious phenomenon known as cathode rays, but he found something he didn't quite expect. He discovered the electron, a particle much smaller than the atom, the supposed indivisible unit. This was a revelation. The ancient idea of atomos was turned on its head. If the atom could be divided into smaller particles, then what else was hiding within these tiny building blocks of matter? This watershed discovery was the birth of particle physics, a field devoted to uncovering the smallest components of the universe. The discovery of the electron opened the door to a world teeming with an array of particles. It was like peeling back the layers of an onion, revealing more and more intricate layers beneath. And with each new layer, our understanding of the universe deepened. This was more than a scientific pursuit. It was a journey into the heart of reality, a quest to understand the very fabric of the universe. Each new particle discovered was a piece of the cosmic jigsaw puzzle, a step closer to the complete picture of the cosmos. The discovery of the electron was not the end, but merely the beginning of the story. Each subsequent discovery, each new particle, represented a new chapter in the unfolding narrative of particle physics. And thus, the journey of discovering the universe's smallest building blocks began. The quest continues today as scientists around the globe probe deeper into the heart of matter, pushing the boundaries of our knowledge and venturing further into the uncharted territory of the subatomic world. As we moved into the 20th century, the world of particle physics took a quantum leap. The stage was set for a revolutionary shift in our understanding of the universe. The early days of this century saw the birth of quantum mechanics, a theory that sought to explain the behavior of particles at the atomic and subatomic levels. The pioneers of quantum mechanics were a group of brilliant minds, among them Max Planck and Albert Einstein. Planck, often regarded as the father of quantum theory, proposed a radical idea that energy is quantized, meaning it comes in discrete packets called quanta. This was a significant departure from the long-standing belief that energy was a continuous flow. Following in Planck's footsteps, Albert Einstein, one of the most influential figures in the history of science, made considerable contributions to quantum mechanics. His explanation of the photoelectric effect, which proposed that light also behaves like a particle, won him the Nobel Prize in Physics in 1921 and further cemented the validity of quantum theory. While quantum mechanics was taking shape, another important discovery was made in the world of particle physics. Scientists had long known about the existence of electrons, negatively charged particles that orbit the nucleus of an atom. However, the constituents of the nucleus itself remained a mystery until the early 20th century. The discovery of the proton, a positively charged particle, and the neutron, a particle with no charge, unveiled the inner workings of the atom and further enriched our understanding of the physical world. Quantum mechanics, with its counterintuitive principles and strange phenomena, opened up a whole new world of possibilities and mysteries. It challenged our perceptions, pushed the boundaries of our knowledge, and set the stage for the astonishing developments in particle physics that were yet to come. It was a quantum leap indeed, one that transformed our understanding of the universe and our place within it. Fast forward to the late 20th century, the golden age of particle physics. Theoretical frameworks had been taking shape, and one such framework that emerged was the Standard Model. This model is like a periodic table for elementary particles, and it's become the cornerstone of our understanding of the subatomic world. The Standard Model classifies all known elementary particles into two types: quarks and leptons. These are the building blocks of matter. Quarks come together to form protons and neutrons, while leptons include the electron and the electron neutrino. The discovery of quarks was a significant leap in our understanding, made possible by scientists like Murray Gell-Mann and George Zweig. They proposed a model where protons and neutrons were not fundamental, but made up of these smaller particles, the quarks. Alongside quarks and leptons, the Standard Model also incorporates the four fundamental forces of nature. These are gravity, electromagnetism, and the strong and weak nuclear forces. Each of these forces is mediated by particles known as bosons. Photons, for instance, mediate the electromagnetic force, while gluons mediate the strong force. Now let's not forget the contributions of one of the most brilliant minds in physics, Richard Feynman. His work on quantum electrodynamics, a theory that describes how light and matter interact, was groundbreaking. Feynman's diagrams, as they're now known, have become a staple in the field, providing a visual way to calculate complex interactions between particles. Despite its complexities, the beauty of the Standard Model lies in its simplicity. It's a testament to human ingenuity, a map of the building blocks of reality as we know it. It's allowed us to predict the existence of certain particles before they were even discovered, like the Higgs boson, a particle that gives others their mass. But it's important to remember that the Standard Model, as comprehensive as it is still incomplete. It doesn't account for gravity at the quantum level, nor does it explain the mysterious dark matter and dark energy that make up most of our universe. But that's a topic for another time. The Standard Model is our current best description of the universe at its most fundamental level, and as we delve deeper into the quantum realm, who knows what new discoveries await us. But the story doesn't end there. Particle physics is still evolving. Our understanding of the universe has expanded significantly in the past few decades. One crucial advancement was the discovery of the Higgs boson in 2012. This elusive particle, often called the God particle, was predicted by the Standard Model but remained undetected for nearly half a century. Its discovery filled a significant gap in our understanding of how particles acquire mass. The Higgs boson is proof that our universe is filled with fields we cannot see. When other particles interact with these fields, they gain mass. Imagine walking through a room filled with invisible water. The water slows you down, effectively making you heavier. That's similar to how the Higgs field works. Yet even with the discovery of the Higgs boson, there's so much more we don't know than we do. The universe is a vast, complex, and often baffling place. It's estimated that ordinary matter, the stuff we and everything we can see and touch are made of, accounts for only about 5% of the universe. The rest, that's made up of dark matter and dark energy. Dark matter, despite its ominous name, is simply matter that we can't see or detect directly. We know it's there because of its gravitational effects on galaxies and galaxy clusters. Dark energy, on the other hand, is even more mysterious. It's thought to be the force driving the accelerating expansion of the universe. But what exactly these are, we're still trying to figure out. These mysteries represent the frontier of particle physics. Scientists around the globe are using cutting-edge technology and innovative methods to unravel these cosmic enigmas. The hope is that by understanding these unseen aspects of the universe, we'll be able to answer some of the most profound questions about our existence. So, don't forget to subscribe for more content on the exciting developments in the world of particle physics. The journey into the unknown is just beginning. The universe still has many secrets left to uncover. So what have we learned on our journey through the evolution of particle physics? We've journeyed from the birth of particle physics, where scientists first discovered that atoms, once thought to be the smallest units of matter, were made up of even tinier particles. We've dived into the quantum realm, where the laws of physics as we know them take a back seat, and particles can exist in multiple states at once. We've charted the Standard Model, the theoretical framework that describes the fundamental particles and forces that make up our universe. But we didn't stop there. We've ventured beyond the Standard Model, exploring theories and experiments that hint at new particles and forces yet to be discovered. Along the way, we've seen how particle physics not only helps us understand the universe at its most fundamental level, but also impacts our daily lives, from medical technologies to computing and even the screen you're watching this video on. But this is just the tip of the iceberg. There's a whole universe of particles out there waiting to be discovered, and with every new discovery, our understanding of the universe evolves. We encourage you to dive deeper, to explore more about particle physics and its fascinating mysteries. The quest to understand the universe continues, and who knows what we may discover next.